So after all these nice presentations with these perfect products and capable products, I have to put a little bit now water into the wine because we are a system integrator and a consulting house for counter-UAS solutions, and we have more than 5 years experiences with all these systems and products. I'm in the UAV DACH. I'm the head of the group for counter defense, and my most part of my role is within EC Aerospace. I'm the CEO here in the Munich site. We have other sites in Prague and in the US, in Florida, Orlando, and so we are developing electronics for drones and satellites, and we have developed a solution in the cybersecurity area for data integrity. And today I will present you some experiences we did in the last years regarding counter-UAS. And so let's start with the slides. So here you see a typical situation. So we differ between cooperative and non-cooperative drones. And what the police told us is, independent of what you have, if you have a weapon or if you have a drone, so you have always around about 5% of owners of equipment, of this equipment, which we don't care about any rules, and yeah, they want to achieve other goals than the normal drone traffic you have. So, and for this situation, we will continue in the next years, and you have the situation that in the past you had a protected area, and now the airspace is free, and you can enter with a small or big drone, whatever you have. You can get access to areas which were not possible in the past. So, and in principle, you have the three ways of how a drone is controlled. So you have remote control with FHSS or Wi-Fi. The same for the communication, or you can control a drone by GNSS, or it can be pre-programmed coordinates, which is completely automated. And depending on these controls, the counter parts, the countermeasures should be handled that. So principally, you have a drone detection, tracking, and verifying area phase, and you have a drone defense, deflecting and destroying phase. So I will get to this later. And you have a lot of challenges by detecting and avoiding drones. So first of all, your technology should be able to work 24/7, 365 in all weather conditions. And the goal is that you minimize false alarms and that you maximize drone detection rate. And this is a problem for a lot of sensors. And yeah. And what is also important in the counter-UAS area that is time. So the drones, they are flying quite fast, so it's easily for a drone to fly 45, 50 kilometers an hour. But there are also electrical drones which can fly more than 300 kilometers an hour. So, and you have not very much time to detect and to defend the drone. Yeah. These are the processes we normally use for drone detection and defense. So you have automated detection, you have automated tracking, and a manual verification. And then if the drone detection is done, so you try, depending on the drone and the situation, there are also it's necessary to defend the drone until to the destroying. And so depending on the rules in every country, for example, here in Germany, it's only allowed for the police to do the defense normally, or perhaps in the future also for some security private companies, this depending on the rules. And this is a typical system architecture of a counter-UAS system. So you have in the middle, you have a management system. We saw this in the first presentation, this software you have, and this software can control several sensors like radar, like RF finders, cameras, acoustic sensors, and you have effectors like, for example, RF jammers, high power electrical magnetical sensors or hijacking sensors. And all this information will go to the control center, and then you can do several actions, not only technical actions, you can also do organizational actions and legal actions. So what are and here this is the same what was already presented. We are also providing consulting services for site planning to find out the coverage of everything and creating heat maps. So, and here are some pictures of a project we did with sensors. And what was also mentioned in the first presentation, that it is very important that you test these sensors. We agree to that. And what are the real challenges now? So there was in Germany at the Frankfurt and Munich airport, there was a big challenge where I think 7 or 8 different companies were challenged about their sensors, and they really flew with drones there, and they tried to really manipulate these drones so that it's not possible to check them. And this worked very well. And so the results of this worldwide, probably one of the biggest challenges is that most of the sensors completely failed. So they didn't detect anything, or wrong, or they detected drones where no drones were, and they missed to detect any drones. So there's a long way to go until really these systems will work and have a quality that they at least detect more than 90% of the drones. And these are the challenges in the future. Another challenge is that the range of these detectors are too small. So for example, RF finders, you have 2 to 3 kilometers max. And for the best radar systems, which are very, very expensive, you have between 10 and 15 kilometers. And you need a 3D radar instead of 2D radar and all these things. So from my point of view, we are very much at the beginning of development for these sensors, and that the suppliers of these sensors, they have a lot of homework to do in the next years. A next big challenge is that the sensor fusion. If you are using, for example, a radar system, an RF sensor, and a camera, and you get 3 different detections, then you have a problem. You don't know which one is the right one, and so you have to do a sensor fusion, and you have to add quality to each sensor and make a valuation which information you would use now. So and what you should you consider before you invest in a drone detection and defense system? The most important thing is, besides simulation, and you will never can do a simulation which is good enough to know if the system really will work. So you have to put it. Do you have to do an installation on the real estate you would like to protect? Not anywhere else. Really, where you're because you have a lot of influences there. You have, for example, fences. You have glass in buildings. You have RF like radar systems or mobile base stations, and there are so many possibilities which can reduce the capability of your sensor, so that you really have to prove it and try it out before you invest in these things. I was asked about the EASA rules. So on the EASA side, there are not so many definitions right now about any requirements to these counter-UAS systems, and we think that counter-UAS has something to do with communication, and what is very important for communication is standards and certification, and this is completely missing right now. So, and this is the challenge for the next years, to find a European-wide or worldwide standardization, not only for counter-UAS systems, also for all the systems which will present the airspace very realistically. And so this has to be done, that all these systems can communicate with each other, that the interfaces are standardized and defined. And there's a long way to go until this will happen, because there's only, and this is my last sentence, there's only one airspace. And you have cooperative or non-cooperative drones there. And it's important that you have also remote systems which can all control these airspace. Thank you.